Good afternoon. Thanks for coming. My name is Phil. I'm here with Casey and Qasid. And we want to talk to you about making accessibility easy on Android. Thanks. So first, a bit about what accessibility does. And ultimately, a lot of engineering ends up being about assumptions, right? We find that, usually when we find that when we've made an assumption, we eventually discover it when we realize it's not right. And that happens a lot with accessibility. It's really easy to make assumptions about what people, particularly people with disabilities, can and can't do. If you meet somebody who uses a power wheelchair, you might make an assumption that they probably don't play soccer. And this, on the face of it, might sound like a pretty plausible assumption. But then you haven't seen my son's power soccer team. There was a World Cup of power wheelchair soccer. So whatever, if you meet somebody who's blind, I've heard people who are, for example, using photo carousels, thinking, well, maybe blind people wouldn't be interested in keeping track of photos. No, we now have technology to let blind people take pictures of things, and they're very interested, it turns out, in sharing them with people. And then there's sort of the simplest one, which is making the assumption that somebody who's not able to move their mouth can't speak. But of course, Stephen Hawking demonstrated that that assumption is wrong long, long ago, and thank goodness he did. So on Android, we make a lot of assumptions it seems like a lot of assumptions sort of built into our devices. You take a touchscreen device, you might assume that all of the users are able to touch the device, or that they can all see what's on the screen. But of course, that turns out not to be true. And so these assumptions, we have to learn to kind of question them. So otherwise, they become obstacles. And so a lot of what accessibility really is about helping people with disabilities overcome obstacles. And the first thing is just to make sure that the obstacles we're helping them overcome are the ones inherent in their disability, not the ones that we've created by making additional assumptions about what they're interested in, what they're actually able to do. So the way Android does accessibility is it depends on the entire ecosystem. So we who work directly on Android, we build a lot of the core of it, but we really depend on the entire ecosystem to make this work. So the accessibility framework is going to handle a lot of low-level features, things like magnification. As a developer, you're not going to build a magnification experience into your app in order to help, so that if we try to do that into every single app on Android, we're going to end up with just a nightmare experience. And also, it's something that's really best handled down close to the graphics level. We want to just magnify things. Accessibility developers, people who work on accessibility services like TalkBack, Switch Access, Voice Access, Select to Speak, they build these plugin services, and the idea is that they will generally have a particular type of user in mind, and they'll go through and really understand what those users need, what their challenges are, and try to build something that works for them. But they, of course, can't do everything on their own. They need to get information from, like if somebody is blind, you need to be able to speak what's on the screen. We need to find that out from the apps, what's actually going on in the UI, and that's where we really need the help of the entire ecosystem and all developers. So our general model is we have these plugin services. So in this case, Switch Access, Voice Access, and Braille. And they're able to query an API for the accessibility service to find out, tell me what windows are on the screen. Tell me what the views are inside these windows. What text is where. What actions are available on each view. And then they can present this to the user in whatever way they need to. If the user's not able to touch the screen, do you want to activate this control, that control? Do you want to perform this gesture? And do it on their behalf. But we really need the apps to provide the right semantics to do that. We want to try and make this as simple as possible. So just a few things to kind of keep in mind. One is just to make sure that the information that you're presenting to all your users is as visible as possible. So luminance contrast ends up being kind of the most important single thing that you can do in that regard, just to make sure that you're not using gray on slightly lighter gray to convey information. And sometimes that can end up looking kind of cool, but it becomes very difficult for some people to use. A second thing is to just prefer controls to be big and simple. It's sometimes a temptation to cram a whole bunch of stuff into a small area to get as many options as possible for users. And often just trying to figure out what is really important for your users can simplify things for everybody and also make it possible for somebody who perhaps doesn't have perfect dexterity to use it. And one thing is we have sort of a general 48 by 48 density independent pixels is sort of a guideline that we throw out there just to kind of have a uniform standard throughout the ecosystem. And that can be set with just like a min height, min width thing. And the other is to label stuff. So if you're conveying information visually, particularly what a button, if there's a button that just has an icon on it, just to provide a label. And these labels should be concise and precise so that users who are not able to see the screen can find out what they do. Sometimes people ask, when in my project should I consider accessibility? So the three-word answer is early and often. The slightly longer answer is in each of these different phases of your project, there's sort of something you can do. So in design, generally the things that I just already mentioned of keeping contrast, control size, labels, that will get you a long way if you're using kind of standard UI patterns. But the more innovation you're doing on your user interface, the further away you're going to get from sort of the stuff we built into the Android framework. And at that point, it's really helpful if you can start thinking more broadly about how the full range of users who are going to use your project, your product. So the more gesture type things that you're doing, you want to make sure that you're taking into account how people are going to interact with that if they perhaps can't perform that gesture. During development, we have a series of APIs. Qasid's going to present some of those. And for testing, we have a number of testing tools to kind of help make sure that, as much as possible, we can automate the process of making sure you're handling these things correctly. So I just explained a whole bunch of stuff about all the complexities of users and all these different things you can do. So you could be forgiven for wondering why we said making accessibility easy. I did say making, not that we already made. But in general, what we want is we really want this to be easy. I think we want that to be, we want to make sure that we're doing that, and if we're not, please let us know. But if you're using standard components in standard ways, it really should be as simple as what I've already said, that you should just be having to label things. The questions that you need to answer should not be complicated questions about how is a particular type of user going to use your project. It'd be something like, what does this control do? But as you evolve in more non-standard ways, it is going to get less easy. But what we want is to make sure that the sort of incremental work that you do for accessibility sort of grows more slowly than the work you need to do to serve whatever users you have in mind to begin with. And now Qasid's going to talk a bit about sort of a way to think about the development process for folks with disabilities.
Hey guys, my name is Qasid. I work for Phil on the Android accessibility team. So let's get right into it. Now, if you really think about it, there are two ways that your user can interact with your application, right? The first is consuming information. Now, this can be content that your user wants, or it could be indications on how to use your UI. And the way we consume information varies dramatically from user to user. So for example, I consume information by looking at what's on screen and consuming and processing it in that way. A talkback user, on the other hand, will hear a description of what's on screen from the device's speech synthesizer, right? Now, once a user has consumed and understood that information, and they've combined it with information from the real world, they can then act on your application to make it do things. And just like consuming information, this varies dramatically from user to user and from circumstance to circumstance. Now, these actions can be something like a tap, a swipe, a scroll. It can be speaking into a device. Some Switch users even drive the whole device with a single button. Now, once we combine these two modes of interaction, we see this cycle of action and information, right? And we can see that if any part of this is subtly broken for a user, our applications become fundamentally useless. So our goal becomes, how do we make sure that this is complete for every single user? Now, that seems like a daunting task because, like we've mentioned before, the ways that the users interact with our devices actually varies quite a lot. And trying to understand those users is quite a complicated task. But if you don't try to do anything too non-standard and you trust us and you use our APIs, then this is actually a pretty easy task. So I'm going to show you some trivial things you can do, which are fundamental, and also push your accessibility to be much better than it otherwise would have been. Let's start in the ways that we break consumption of information. Now, for the purpose of this, I've created this nice little search application, a novel idea. And the way that I'm indicating that this is a search UI is that by that magnifying glass on that little line. Now, right away, you're going to notice something. That's a very light shade of gray on a very slightly lighter shade of gray. And that's going to be difficult for people who, that's going to be difficult for a lot of people to see, because that's a very low contrast ratio. It can be frustrating and downright impossible for others. So what we should do is we should darken it up. And just like that, many more people are able to use our application. The goal here is make sure all of your information is visible in terms of size and contrast. And if you want concrete guidelines on this, you can go to the material website, and we can give you contrast ratios in different circumstances, and also hard numbers in terms of size, like the 48 by 48. Now, that was kind of straightforward, but there are clearly some dramatic variations in how we consume information. And for those situations, what we want you to do is we want you to fill in the blanks for our frameworks. What I mean by that is our framework can infer a lot from your view hierarchy from the code that you've already written, but there's some situations where we need your help. Let me show you. Let's just say that I'm a TalkBack user, and I'm placing my finger on screen to hear a description of whatever is under my finger. And I place my finger on the magnify icon. Now, I want to hear what that is. But unfortunately, there's no way for our frameworks to figure out what that means, because there is no text associated with that. I mean, it's essentially an arrangement of pixels on screen. So you guys have to fill in the blanks as app developers. And you can do that by adding a label. So in this case, I decided to label it search. Make sure you keep your labels concise and to the point. If it's something that indicates an action, then make it a simple action verb. This is actually pretty easy. In this situation, all you do is you set the content description. Make sure your string is localized, because it's a user-facing string, and accessibility users don't only exist in America. Now that our user can generally understand what's happening on screen, let's make sure we allow them to act on our device appropriately, or act on our application appropriately. So I decided to add a new feature. It's a clear text button, so you can easily, instead of having a backspace, you can easily reset and start typing again. But that's a really tiny button. You know, I'm going to have trouble tapping that, and someone who has some sort of fine motor disability is going to have a lot more trouble typing that. It might just be impossible for them. Let's make it bigger. And now, again, this works for many more users. Like Phil mentioned earlier, make sure your controls are simple and they're large. So I decided to add another feature. I decided to add a history feature. Here, you can tap any of the queries and see the results of the query again. Now, if you end up swiping on any of these items, you'll end up seeing a trash icon indicating that this item can be removed from history. And if you continue swiping, that item will be removed from history. So this is great and all, but this is a pretty custom-built gesture overloaded onto an item. And it's going to be hard for our frameworks to detect. So again, you guys are going to have to fill in the blanks for our frameworks and for accessibility users. Now, you can do that by adding an action, or an accessibility action. And all you have to do here is specify a user-facing label or description of that action, again, a simple verb, and the bit of code that should be executed when this action is performed. Currently, you can do that with the Accessibility Action API, but we are actually adding something to the Android X library, which allows you to do this in a single line call with a lambda and a string passed in. So I've shown you a way of thinking about accessibility issues and how to address them, but you still need to know how to find these issues and how to verify that you've actually fixed them. This is where Casey comes in. Casey?
Thanks, Qasid. I'm Casey Burkhardt. I'm a software engineer on Google's accessibility engineering team, and I lead the development of accessibility testing tools for Android. So as Qasid had pointed out, there are many common accessibility issues that actually fixes are fairly straightforward from the development side and can really improve the accessibility of your app. A big question, though, is how do we go about finding those issues? And there are three types of accessibility testing today that I'd like to cover. There's automated testing, use of automated tools, manual testing, where you use Android's accessibility services yourself to understand the user's experience, and finally, user testing, where you actually bring in users with various disabilities and truly get their feedback and understand their experience using your application. My section of the talk focuses mainly on automation, because right now we see that as one big area where we can make vast improvements across the ecosystem if we have some developers' cooperation using these tools. So automated accessibility testing, until several years ago on Android, didn't really exist. In around 2015, we launched a project known as Android's Accessibility Test Framework, which is an Android and Java library that essentially houses a lot of detection logic for the more common accessibility issues that we can identify within an app's UI in sort of a rule-based fashion. This is an open source project, so you can go and find it on GitHub. And essentially what it's aiming to do is look at your app's UI at runtime and find some more of the automatable mechanical aspects of accessibility that we see day to day that affect users the most. So we can find a lot of the common issues that Qasid discussed. So we can tell you if you have a control within your UI that is missing a label for a screen reader. We can identify low contrast text and images. We can tell you if you've got clickable items within a UI that fail to meet our minimums for touch target guidelines. And we also identify a number of various other implementation-specific issues. And the core testing library, ATF, is sort of growing constantly to find more new and interesting issues. We've taken this library and we've integrated it with common developer endpoints, essentially tools that you'll use commonly throughout the development lifecycle, and you can leverage throughout your project. I want to talk through some of those integrations today and how you can use them and get started with them quickly. So first and foremost, we've got integrations with two test frameworks that are pretty commonly used throughout unit and UI tests on Android apps. The first is Espresso and Roboelectric. So essentially, the idea with these integrations of ATF is they will piggyback on top of your existing tests. So you have a test that runs, loads some UI from your application, interacts with that UI, and asserts some state. During the interaction phase of your test, if you've enabled our integrations with Espresso or Roboelectric, we'll actually evaluate the UI at the time that it's interacted with. So if we identify an accessibility issue that we believe will affect a user with a disability's ability to interact with your application, we will fail your existing test. So if you already have strong test coverage with either Roboelectric or Espresso, enabling ATF's integration with that test framework might be a great way to get a decent amount of coverage for automation in terms of accessibility testing throughout your app. A few other points to note here. Each framework offers what's known as an accessibility validator. And this is an object that you can use to essentially configure ATF's behavior inside of your tests. So you can configure ATF, for example, to not fail your test and just log something if we've run into an issue. You can set up ATF to crawl from the root of your view hierarchy whenever you perform an action, rather than just evaluating the item that was interacted with. It's a great way to get some additional coverage. And you can even use Accessibility Validator to set a whitelist. So if you want to turn on accessibility tests within your Roboelectric or Espresso tests, you can do so, maintain sort of a green pre-submit, and burn through issues that you know about by creating and registering one of these whitelists for known issues. So specifically inside how you leverage these between Espresso and Roboelectric. In Espresso, you're going to essentially call accessibilitychecks.enable from within your tests setup. This is going to essentially trigger our global assertion to run whenever you use a view action within an Espresso test. So in this case, the view action is run. We'll perform an evaluation on the view that was interacted with and its subtree. Accessibility validator is actually returned by the call to accessibilitychecks.enable. So if you need to further customize ATF's behavior, you can do so from the object returned from that call. Within Roboelectric, it's slightly different. So instead of calling accessibilitychecks.enable, accessibilitychecks is an annotation, and you'll annotate your test method or class that you'd like to enable accessibility checking within. And it relies on you using shadowview.clickonAll to actually interact with elements in your UI through your Roboelectric tests. So avoid the temptation to use view, perform click directly. The accessibility validator functionality is available in Roboelectric through a different class that mirrors the same API. You can just look for accessibility util and make static calls there to configure ATF's behavior. So in addition to integrations with these automated test frameworks, we've built a separate standalone tool known as Accessibility Scanner. This is a direct integration of ATF, but Accessibility Scanner sort of acts as a front end for the library. It will evaluate the foreground UI of your application at runtime on an actual Android device. And the way it works is essentially you install Accessibility Scanner, you turn it on, it will add a floating button globally to the device's screen. You'll open up your application, navigate to the UI that you'd like to evaluate, and just tap the button. And what you see is essentially a report that describes the ways in which you can improve that UI for accessibility. And again, these will mirror the same types of issues that ATF and Espresso and Roboelectric can identify as well. It's very easy to take these reports from Accessibility Scanner and share them with your team. You can currently export to email or Drive. And it doesn't really require technical skills. You don't have to have a debug version of your application or a user debug device. You don't need to do anything special to set this up. It works on any app on any Android device running Marshmallow or later. And really, you don't even have to have a lot of experience related to accessibility. Each issue that Accessibility Scanner can identify comes with extensive documentation that gives you background on how that issue might affect users and how to think about that issue during the design, development, and test phases of your project. So please do download Accessibility Scanner. It's something I highly recommend we use when we build UI. g.co/accessibility scanner will take you to the Play Store page. Finally, one last integration I'd like to cover today, and this is a new one. We've launched it a few months ago. It's an integration of our accessibility testing framework and the Play Store Developer Console's pre-launch report. For those of you who haven't used pre-launch report yet, it is a great tool to sort of get a sanity check during the launch process, the release process, for an APK to the Play Store, either on an open or a closed channel. Essentially, the way it works is you upload an APK. Pre-launch report will take that APK, instrument it, and push it to a number of different physical devices in a lab. And we'll crawl your app essentially on these different devices and generate reports that include findings about performance, security, and now accessibility as well. So ATF is running alongside pre-launch report as it's crawling your application, and it's generating reports at each stage in the crawl. And it's taking all of the results and sort of deduplicating them. So if you'd like to check this out, it's available now in Play Store Developer Console under Release Management. And you should be able to see accessibility results for any APK that you've uploaded to the store since fairly early in July. So please do check that out. And here's what it looks like, just to give you an idea. Here, the main entry point for an APK will show you all different categories of issues that we've identified. It will show you clusters of issues. You can click on any one of those, and it will show you more details about the specific problem. So in this case, we're pointing out an issue relating to touch target size. And in the column on the left, you see many different examples of that same deduplicated issue across different crawls of your application that pre-launch report has performed. You have access to the same additional documentation here as well, too. So if you're not familiar with a particular issue, the Learn More link will give you the details you need to resolve it, regardless of what stage your project is currently in. So I want to wrap up by talking about an accessibility testing strategy. We talked a lot about automation, but we didn't go into too much detail on the other two, manual testing and user testing. And these are equally important. Automation is great because it helps you find issues very quickly early in the development cycle, especially if you have good test coverage with our automated tools. So essentially, think about automation as a way to catch very common issues quickly, but not as a way to guarantee that your app or your UI is fully accessible. To really understand your user's experience, to get that awareness of how your UI is actually performing with an accessibility service, we really highly recommend you go and actually turn on TalkBack, turn on Switch Access, try them out, learn how to use them, and gain a true understanding of your user's experience. The way I like to describe it is automation is capable of finding a missing label for a screen reader, but we can't really tell you if your labels make sense. So really only by understanding, putting yourself in the user's shoes and understanding their experience, or asking users directly about their experience, only then can you truly understand how accessible your UI is for users with various different disabilities. And we have found at Google, both looking at our first-party and third-party applications, the most successful, the most highly accessible apps that we see day to day are the apps that combine multiple accessibility testing strategies. So those that leverage automation during pre-submit or continuous integration, but also have a regular process for manual accessibility testing or bringing users in and understanding their perspective on the accessibility of an application. So these are all things to consider. With that, I'll hand it back to Qasid, who's going to talk to us more about some of the newer APIs for expressing app semantics.
Hey guys, I'm back. So let's just say that you've adopted the APIs that I've talked about earlier, and you've adopted the testing that Casey has suggested. And at this point, you've got a pretty good foundation of accessibility in your application. But the more you're testing, the more you realize that there's some holes in your experience. And that's breaking that cycle of interaction that I mentioned earlier. So we've been adding new APIs and new things to make it so these holes get plugged. So the first things first is clickable spans, those little clickable bits of text. Before API 26, non-URL spans were fundamentally inaccessible. And developers had to write a bunch of hacky workarounds to make these things work. That's now changed. In addition to that, in the latest alpha of the Android X library, we've added API to make this work all the way back to API 19. So you can look out for that too. Secondly, there's some views that, as far as the user is concerned, act and behave like windows. They have their own special content, their own lifecycle, so on and so forth. And we call those accessibility panes. Now, you as a developer need to inform our frameworks to present these a little bit differently to the user. And the way you do that is by passing a non-null string to set accessibility pane title on the view. And again, this is a user-facing string, so make sure it's concise and it's localized. This is available in API 28, but we've also added this API to view compat in the latest Android X alpha, and that'll work all the way back to API 19. And finally, there are headings. These section titles are used by talkback users, for example, to navigate through sections quickly and easily. And the way you specify that is exactly what you'd probably expect. Pass in a Boolean to set accessibility heading on a view. This is also available in 28, and we added this to the latest alpha of the Android X library. That'll work all the way back to 19. Either way, thank you for your time. Now it's back to Phil.
All right, so sort of circling back to the title of this, which was making accessibility easy. We really want this to be easy. It's the only way that that users with disabilities are really going to be able to access the ecosystem. Because occasionally we'll encounter somebody who's really willing to do the extra mile, really dig into their app and sort out all of the issues for accessibility. And that's great, but not every developer can possibly do that. And so we need to make this as easy as possible so that everyone can kind of build this into their workflow in a really natural way. And so certainly to get the basics, we want it to be straightforward. So if you've got reasonable contrast to make the information visible to everyone, you've got simple big controls, you're using labels, we really want that to kind of get you almost all the way. And then some of these other APIs, like Qasid was just describing, should be able to handle some of these more specialized situations. Like if you've got a full screen fragment transition, you can use the pane title to make sure that gets handled the same way a window transition would. Saying that we want it to be easy, it means if it's hard, we've messed up, and we should fix that. We found some developers will well, the framework seems to be coming up short here, so I'm going to engineer a sort of a workaround to kind of get around the problems with the framework. Honestly, please don't do that. Let us fix it, because we can fix it at scale, and only we can. It needs to be fixed inside Android. If you find it in Android X, if you want to fix it, by all means, upload it to Android X, and we're happy to accept fixes. But we want it fixed centrally so that we can get a consistent experience throughout the whole ecosystem. If you are engineering some super custom solution, you can think, is an engineer working at a different company going to actually do this work? And if the answer is no, then there's probably something wrong. And so please reach out if we're messing this up. You can file bugs on AOSP. You can ask questions on Stack Overflow. But we'd much prefer we really prefer to get the feedback that something is difficult so we can try to find an elegant solution that everyone can use. We want some of the things that Qasid just presented before he did that work. The effort required to do some of these things really required like learning a new API surface. And we really wanted to condense everything we could down to like one line. And so we were trying to present solutions that really are like, if you've got this thing, here's one line of code, it's all you need. If you get to something that seems like it should be one line of code and it's not, let us know. And another place to go just for other resources is g.co, Android accessibility. There's a link here to the developer.android.com for accessibility testing, the link to get to the accessibility scanner, and also the test framework project that Casey described. That's available open source on GitHub if you're interested to look at that. So really appreciate your time, and we'd be very happy, especially if you've got feedback for us about things that should be easier than they are. We're going to also be out at the office hours for a while this afternoon. We'd really love to talk to you. So thanks a lot for coming and for your efforts in helping to make a consistent ecosystem of very accessible apps. Thanks.